Programming a Terasic Intel FPGA board with TINA, using schematic design entry. In this tutorial video, we will show you how to create a digital circuit and download it to a Terasic DE10-Lite FPGA board, using TINA's schematic editor.
In a similar way, it's also possible to download digital circuits to the FPGA of DesignSoft's Lab Explorer. The schematic design may contain gates or other built-in digital components in TINA, or macros defining digital components with hardware description languages such as VHDL or Verilog.
In this video, we will use a free Intel tool, Quartus Prime Lite Edition, which is required for the Intel Max 10 FPGA and the Terasic DE10-Lite board. For other Intel FPGAs, you might need to use the standard or Pro edition of Quartus.
These tools will be responsible for creating configuration files for the FPGA programmable logic.
We presume that the board is accessible from your machine and that the necessary drivers have been installed.
Now, let's see an example. Start TINA. Then open the halfaddergates.tsc file from the examples folder of TINA. The half-adder is a simple combinational circuit to add two single binary digits and provide the output plus a carry value. It has two inputs called A and B and two outputs called sum and carry. This schematic diagram contains basic OR and inverter gates, high-low switches, and logic indicators. Note, you can find more information about the half-adder circuit in our previous video, Simulation of a Half-Adder with 4 Basic Gates using TINA. To test the circuit, press the Dig Interactive button. If TINA is in a different interactive working mode, select Digital from the interactive menu. The mode name on the interactive mode button will change to Dig. Play with the switches by toggling between low and high levels to produce all the input combinations. If both inputs are low, then sum and carry are also low. If just one input is high, then sum is high and carry is low. If both inputs are high, then sum is low and carry is high. Now, before testing our circuit in a real FPGA development board environment, we need to extend our schematic with FPGA pin connectors from the special toolbar of TINA. Pin connectors as certain elements such as clocks, push buttons, and LEDs are pre-connected to the FPGA chip's pins on the development board. The FPGA development tools call them constraints. Now, modify the schematic by adding the FPGA pin connectors. FPGA pin from the special toolbar and add 4 FPGA pins to the circuit's inputs and outputs, as shown next. Connect the first FPGA pin to input A. Double-click pin 1, and in the FPGA pin window, click the 3 dots at the end of the pin settings field. The FPGA pin setting window appears. The device settings section of the window contains the list of supported boards in the TINA system.
In the group section, the types of input-output parts, e.g., SW, switches, on the selected board, e.g., the Terasic DE10-Lite are listed.
Once you select a type in the group settings section, e.g., switches, in the pin type settings section, the connection pins of the selected type of parts appear, e.g., SW0. These connection pins should be associated with the corresponding nodes in the TINA schematic. We'll rename the FPGA input and output pins, including their labels, accordingly, as those on the FPGA boards, to which they will be connected. For the inputs, we will use SW0 and SW1.
And for the outputs, LEDR0 and LEDR1. From the device setting list, select the Terasic DE10-Lite. Next, click SW switches under the group settings section.
Then select SW0 from the pin type setting list on the right side. Then click OK. In the FPGA pin window, rename label pin 1 as SW0 as well. Then click OK. Select the next FPGA pin and connect it to input B. Then rename it as shown next. Rename its label as well. Now connect the half-adder circuit outputs to the LEDs. Place the FPGA pins and select the proper entries.
For some, use LEDR0 as output.
Repeat this procedure for carry.
Rename carry as LEDR1. Now, let's see how to generate the source file for Intel Quartus Lite.
Create a folder. We'll name our folder Designs.
Then, click the T&M menu, select Export to FPGA Software, and click Intel Quartus. Save the half-adder-gates.vhd and the half-adder-gates.qsf files into this newly created folder.
Note that Tina always creates a VHD file from any type of representation of the digital circuit.
That is, schematic diagrams, VHDL, Verilog codes or combinations thereof are always translated into a VHD file for Quartus. The QSF, Quartus Prime Settings file guides the FPGA software, for which, the physical pins on the FPGA will be the inputs and outputs. The QSF is made from the FPGA pin settings we made previously. To produce downloadable content, we first have to create the Quartus Prime Lite project. Start Quartus. Select File, then click New Project Wizard. Enter the working directory name, in our case, C:\designs, and the project name, half-adder gates.
Click Next. Click Next again.
Now, add the source file.
From the Designs folder, select the half-adder-gates.vhd file as a source file. Then click Next.
In the Family Device and Board Settings dialog, under Device Family, select Max 10. Now, file by clicking on the half-adder gates file in the Project Navigator. Copy the entity name, and set it as the top-level entity, under the Assignments menu point. Click Assignments and select Settings. Paste the entity name into the top-level entity field in the dialog. Click OK. Let's add the QSF file as well. Click Assignments, and select Import Assignments. From the Designs folder, select the half-adder-gates.qsf file. The content of the QSF file will tell the software which FPGA pins are to be used for the logic inputs and outputs. Click OK. Now, to produce configuration data for the FPGA. Right-click on Compile Design, then click Start. Now, connect the DE10-Lite with the Quartus machine via USB. As soon as the Quartus Prime full compilation was successful message appears. Right-click the program device. Then click Open. Click the Start button to program the device. You will see the progress bar at 100% successful message. And the conf LED will light up on the board. Now, let's see how our simulated half-adder circuit works along with the programmed DE10-Lite hardware. To have a closer look at the DE10-Lite hardware, we will now zoom into the area of the two switches, SW0 and SW1, and the corresponding LEDs, LEDR0 and LEDR1. We will change the virtual switches in Tina by clicking them on the screen, and at the same time, we will also change the real switches on the DE10-Lite board.
If both inputs are low, then sum and carry are also low. If just one input is high, then sum is high and carry is low. If both inputs are high, then sum is low and carry is high. As you can see, in all cases the results are exactly the same. This is a great example of demonstrating the power of simulation, since you can test and debug circuits even before realizing them. And in our case, before downloading to FPGA, where if there were any issues, it would be extremely hard to find the problem. This concludes our video tutorial of programming an FPGA development board using schematic diagrams with TINA's built-in digital components. Check out our video, Programming FPGA Boards in VHDL with TINA, where we use VHDL components in FPGA design. For more information, visit our website, www.tina.com. Visit our YouTube channel, www.youtube.com/user/TINA Design Suite.